No, I can't do this every class, but a lot of the classes this year I'm recording our lessons and I'm putting them on YouTube. So if you don't know where to go on YouTube, I'm going to show you where to go. So you can always get your lessons on YouTube. But that also means you have to behave because I'm recording good and bad behavior on YouTube. So if you don't want me to call out your name in a disciplinary way, don't do anything bad. Okay? All right. You need to know, Abby, you need to know at least 2 of the theorems out of 2.3, and the first one's the remainder theorem. Okay? All the remainder theorem says is that if a polynomial f of x is divided by x minus k, then the remainder is going to be the same thing as plugging k into the function. So if you want to know the remainder of a function by dividing it by x minus k, just plug k into the function, you immediately have the remainder. Guaranteed. That's the remainder theorem. The factor theorem says that a polynomial f of x has a factor of x minus k if and only if f of k equals 0. And for those of you who had geometry, if and only if is a what? For those of you who had geometry. If and only if is a what?
Can't even think of the word.
It's a biconditional.
Ah.
If and if. If and only if. It's a biconditional. Okay. We're going to do long division today. And I'm going to choose a problem first right out of the book. Okay. So, when do I use long division? The answer is when the power of the divisor function is greater than 1. Now there are some exceptions to this, Sydney. There are some exceptions, but by and large, when the power of the divisor function is greater than 1, you have to use long division, okay? And here's a perfect example. We're going to take negative 5x squared plus 2 plus 3x plus 2x to the 4th, and we're going to divide it by 2x minus 3 plus x squared. So the first thing that has to happen is you've got to put everything in descending order. So that means right here is that the first term becomes 2x to the 4th, then plus 4x cubed minus 5x squared plus 3x minus 2. So this has to be perfectly descending right here. Okay? This also, the divisor, has to be perfectly descending. If you don't have perfectly descending, you're going to get a wrong answer. Okay? Now, what we do is we take the very first term, x squared, and what we say is x squared times what gives me 2x to the 4th? X squared times what gives me 2x to the 4th? 2x squared. And so it becomes the first term in the quotient.
Why is it weird? Oh, because you have 3 terms that you have to
Yep.
multiply in.
Yep.
Okay.
Yep. Okay, does that make sense, Seth? Yes? Okay. So now what you do, Seth, is you take every single term right here in the divisor and you multiply it by the first term in the quotient. So x squared times 2x squared is 2x to the 4th. 2x times 2x squared is 4x cubed, and negative 3 times 2x squared is negative 6x squared. And now what you have to do is you have to subtract all of this from this. Okay, so 2x to the 4th minus 2x to the 4th is 0, gone. 4x cubed minus 4x cubed is 0, gone. But what is negative 5x squared minus negative 6x squared? Positive 1x squared. Does that make sense? Remember, you're subtracting this from this, and this is a double negative now. So it's a 1x squared. Now, is the power here the same as the power here? Yes, so we can still proceed. Abby, we have to stop when the power of the remainder is less than the power of the divisor. That's when we stop. So now, x squared times what gives me x squared? 1, so we put a 1 here. And notice we put some space between these. Why do we put some space between these?
Because 1 is the magnitude.
One's the constant. We're missing an x term, right? So we put some space. So now we say x squared times 1 is x squared. 2x times 1 is 2x. Negative 3 times 1 is negative 3. And now we subtract. X squared minus x squared perfectly cancels. 3x minus 2x is 1x. Negative 2 minus negative 3 is positive 1. There's my remainder. The power of the remainder is what? The degree of the remainder is 1, and that is now less than the degree of the divisor. I'm now forced to stop. I'm now forced to stop. So here's the final answer. This now turns out to be 2x squared plus 1, that's the quotient, plus the remainder over the divisor. So open up your books and let's try exercise 23 in the book.
Like number 23?
Number 23, yep. Which is this one right here. So what do I write in here? 2x cubed, and then what comes next? 8x squared plus 3x minus 9, is that correct? And then what goes out here? X squared plus 1. Okay, now immediately right here where it says x squared plus 1, I'm going to erase the plus 1 and I'm going to put a plus 0x plus 1. And that's going to help me. That's going to help me stay perfectly organized. Do you see how that one little thing you got to be careful of? All right, so x squared times what gives me 2x cubed?
2x.
2x, that's correct. Now, this times that is this. This times that is this, 0x squared. This times that is that. Now I'm going to subtract, so this minus this is gone. This minus this is negative 8x squared. This minus this is 1x, and now I push down the negative 9. Did anybody have that after the first step? Okay. Now, x squared times what gives me negative 8x squared? Negative 8. So I'm going to say minus 8. And actually, I haven't done anything wrong, but I've done something in what's called bad form, so let me fix the form. What I should have done, Caitlin, is I should have put the 2x here, minus the 8 there. Make sure everything's lined up with powers. Does that make sense?
Yeah.
Okay. Now I work through this, and so this becomes negative 8x squared. 0 times that is still 0x. 1 times that is negative 8. Now let's subtract. These go away. This is equal to 1x, and this is equal to minus 1. So there's my remainder. Can't go any further. So now the function is equal to 2x minus 8 plus x minus 1 over x squared plus 1. And there she is. Okay, does that make sense? Even though you may not have been able to come to the correct solution, does it make sense now that putting a 0x really helps? And that's really the thing about long division, Seth. It's really not hard. You just have to make sure that you stay organized. Organization is the key to doing it. Okay? Questions, comments, concerns? All right.
Oh, I have a question.
Yes?
So the remainder theorem, what was that again?
Okay, the big picture. The remainder theorem simply says that if you're going to divide a function by x minus k, and if all you want to know is the remainder, then just plug k into the function, and you'll know what the remainder is.
Oh, okay.
So if I was to divide a function by x minus 8, and if I don't care about anything except the remainder, all I have to do is calculate what f of 8 is, and I'll have whatever the remainder is. That's the remainder theorem. The factor theorem says that if I divide by x minus k, and I get a remainder of 0, that means that I have found a factor of the function. And factoring is going to become super important for the rest of the year. This is actually a technique of factoring. You're used to, from Algebra 2, factoring quadratics. You've been doing that for quite a while. Well, now we can factor anything. the moment we found a 0 for remainder, we can factor anything using synthetic division. Okay? All right. Now, I don't have it on my board yet because I haven't had time. There's a couple things I need to... I'll give you the homework in just a second, but there's a couple things we need to go over. First of all, this Wednesday is our next test. 2.1 through 2.3. Okay? This is a very sharp group. This is a very sharp group. Mrs. Doherty last year sung your praises, and I'm singing your praises again. However, the same way that a coach would for a soccer team or a baseball team, a coach will always say, you're doing really good here, but here's where you can do better. Okay? I just want you to take this as an encouragement. Okay? This is a form of edification. You're all a very sharp group, but some of you can be doing better. Okay? Some of you can be doing better. And one of the things that you can be doing better, one of the things that I'm seeing is there's something that you're not sure how to do, so you'll come to me and I'll go over it very briefly, and then you'll say, oh, I get it. I understand the concept now. Well, okay, you understand me doing it, okay? But you don't really understand it until what?
You can do it yourself.
You can do it yourself, and then several times. What I'm seeing from this class is, first of all, you can pick up the concepts relatively quickly. This is like the first pre-calculus class I've been ever able to get this far in this short a time, which is what I need to do anyways, Caitlin, because this is your first college class. I'm exceedingly pleased with the fact that you take on the challenges that's given to you. But one of the things I want you to do is, even if it's just 1 or 2 questions before a test, I want you to make sure, and I'm not saying you're not doing this, but what I want you to do is I want you to take it up a notch, okay? You know you have a test on the horizon. I want you to first cut up your time and say, okay, I'm going to do these ones from the homework that we did. I'm just going to redo them, make sure I understand them, okay? A little bit greater. So don't just assume that the moment you've seen me do something on the board, you understand it. It's not true. You've seen me do it, and I do the best I can to make it understandable. But that doesn't mean that you understand it yet. You've got to deepen your understanding. You've got to dig in for yourself and do some of those problems, okay? Again, a great way to study for a test is just read through the examples in the textbook. That is an excellent way to do it. I don't promise, but sometimes I pull questions right out of the examples because I'm pressed for time and I'm like, ooh, that's a good one. So I'll just pull it out of the examples. That doesn't happen all the time. Okay, so let me just say you're doing good, but you can do better, and kick it up a notch. From whatever you're doing, kick it up a notch. Go through the examples in the book if you're not doing that. Make sure you're doing at least some of the homework questions. If not, redoing the homework questions before the test comes, okay? All right, so this Wednesday is our next test, and it's going to cover just those 3 sections. Same way before, 70% is right out of the homework, and the other 30% uses the math, but in a different way that you have not been asked before. Okay? I keep re-stressing that just for that fact, just so you know how the tests work. Okay? Now, for today, these are the problems I'd like you to be able to do. Numbers 8, 24, 25, I should have put them in order, I didn't. Oops, 22, 23, 26. That's the homework tonight. I made sure I pared it down. There was no reason to give 20 questions. This is good enough. Okay? So Merry Christmas. There you go.
Thank you.
Okay. Now, tomorrow you have the ASFABs, right?
No, what? No, it's not tomorrow, I don't think.
PSATs?
What?
What? Don't you have PSAT practice this week?
Oh. No, this is, the 11th is in 2 weeks.
College Fair. ASFABs are the 26th. Is that not a junior thing?
No, it is.
It is, yeah. ASFABs are the 26th.
What do we do?
So,
What the heck is that?
That's the test that tests your life skills.
The $14 need to be.
Oh, that's for something.
Don't forget to bring in $14 for the PSAT by Friday, October 11th.
So, what is the what it is? The ASVABs.
The ASVABs is just a life skills test.
Alright, and what do we do? And where?
I don't know how you can study for it. I think you can, but I don't.
Alright, what time?
I think it's in the morning.
Until lunch.
Yeah. Tomorrow's a prep day, and then Wednesday is our test day.
Praise Father, Son.
Praise Father.